question number 11 is telling us that we have quadrilateral ABCD that is a parallelogram. Okay, the coordinates they give us, they only give us 3 coordinates. If you look at our graph, we have point A, which is -2, +4, point B, which is -8, +3, and point C, which is -7, -2. And it says which point or points below could be used for point D in order to ensure that ABCD is a parallelogram. So if you recall from our lesson on this, we are going to use the slope to figure out what we need for parallelograms. So this was the chart that you had from your notes, okay? And so what we're looking for in order for it to be just a parallelogram, okay, is that both sets of opposite sides are parallel, which means that they are going to have the same slope. If we were to follow this down, we could eventually maybe have our diagonals be not perpendicular to prove it's just a parallelogram, or a rhombus and a parallelogram. But for this question, we really just need to know, is it a parallelogram or not? So we just need to prove that our opposite sides are going to be parallel, okay? So I'm looking for BC. Okay, so B to C is right here. We want the slope of that line. Okay, now I know it's a little bit tricky to see. Let me see if I can enlarge this just a little bit for you. Okay, so we have B to C, and we want to know what the slope of that line is. So this one's pretty easy to do. I'm going to go ahead and just count the slope right on my graph, okay? So I'm going to start at B and work my way down. This is a negative slope. So I'm going to go down 1, 2, 3, 4, 5, okay? And I do this by making my triangle, okay? So I have a slope of -5, so that was my rise, and then I ran over 1. So the slope of B to C is -5 over 1, okay? Now I'm going to look for the slope of AB, okay? So we're looking for AB. So I'm going to, again, make my... That's a really bad line, I apologize, but I'm going to go up 1 and over 1, 2, 3, 4, 5, 6. So my slope is 1 over 6 for A to B. So what I'm looking for is whatever C is going to connect to, I need that to be a slope of 1 over 6. Okay, so if I have point -3, 1, so I have -1, 2, 3, up 1, I could plot that if I want to. Okay, I want C to this point right here to have a slope of 1 over 6. Now I could just take point C and plug it into my slope formula. So the 2 points that I have for A to C right now are -7, -2, and -3, +1. Okay, so we can use our slope formula. So our slope formula is m is equal to y2 minus y1 over x2 minus x1. I'm just going to show you one of these, and the rest I will just count on the graph for us. Okay, so I need A to C to have a slope of 1 over 6. So in order to do that, I have to plug in my values. So I have an x1 and a y1, an x2, and a y2. Okay, so I'm going to go ahead and plug these in. So we have y2 is equal to 1 minus a -2 over -3 minus -7. And that gets me a 1 over 4. It has a slope of 1/4. Well, 1/4 and 1/6, they're not the same. So that one definitely won't work. And you could do that by counting it on here, okay? So I could go up 1, 2, 3, and over 1, 2, 3, 4. That's still a slope of 3/4. Oh, whoops, this should be 3, not a 1. Okay, so the slopes do not match, so that one will not work. Okay, so we're going to go ahead and we're going to do the same thing for the other points that we have. So I have number 2, and that is point -1, -1. Now I could continue to plug them into the slope formula if I wanted to. But if I just come over here and try and count the slope, I should be able to prove that C to D is parallel to BA. Okay, so that needs to have a slope of 1/6. And A to D, if this is my potential D, is parallel to BC, so -5/1. Okay, so we're going to count. We're going to do you can do a triangle. So I'm going to count up 1 over 1, 2, 3, 4, 5, and 6. That works for B to C, or A to B, I'm sorry. Okay, so now we want to check the other direction and see if they are parallel. So I need this to be -5/1. So I'm going down 1, 2, 3, 4, 5, and over 1. So 2 will work. Okay, so we're going to continue. So far 2 works. So let's check out our other ones. Okay, so now I have a point for D that we want to try out. I have -1, 2, +1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's try to prove right now that AD is parallel to BC. Okay, let's see if they're parallel. Okay, if AD is parallel to BC, it has to be a -5/1. But if I do my rise, I'm going up to here. So up 1, 2, 3, 4, 5, but there's no run. Okay, so that one has a slope of, so A to D in this case would have a slope of 5/0, which is undefined, which is not -5/1. Okay, so that means that number 3 will not work. And last but not least, we need to check -3, +9. And again, I'm going to graph it on here, but if you prefer to find your slope, that is a-okay. So I have -1, 2, 3, +1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is hopefully going to work out. So let's check A to D first. So A to D with number 4 needs to still be -5/1. So I'm going to count up and over. Okay, so hopefully we'll have so this is 1, 2, 3, 4, 5. So that is going to be a negative slope. So that's a -5, and we ran over 1. But let's double check that for our to make sure that AC is also parallel to AD. Okay, so I'm going to count up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. Okay, so that does not work for B to D. So B to D would have a slope of, we said 6/1, 2, 3, 4, and 5. Okay, so that makes it only number 2. So which would be your last one, just number 2. Okay, go ahead and give the next one a try and